Hi everyone, I'd like to take a few minutes now of your time to review how to find prime factorization of a number using the factor tree method. To be able to complete this section of mathematics, you have to make the assumption that you know what prime numbers are as well as factors. If this is not the case, please go back and review. If it is the case, we can move on. So what is this illustrious prime factorization anyway? Well, up to this point, we know that we can take any number and express it as a product of two or more other numbers, even if that product is just one and itself. For instance, 35 can be expressed as 7 times 5. 8 can be expressed as 4 times 2. What makes the prime factorization so interesting and so useful is the fact that your prime factorization is unique for every given number. For instance, even though I can express 16 as 4 times 4 or 2 times 8, the prime factorization of 16 will always be 2 times 2 times 2 times 2. Before we worry about why that's so important, the question on your mind more than likely is, well, how did you get that? Well, that's what we're going to do next. So you'll notice one of the first things I did was I listed the first 15 prime numbers at the bottom of the page for your own benefit, so you don't have to flip back and forth to make certain you know what numbers are prime and what aren't. And now I'm going to do it by demonstration versus methodology. If you'd like a methodology for it, I'm certain I can supply one later on. But as of now, I figure I will just demonstrate how to actually do the prime factorization of 8. So I start by asking myself, is 8 prime? No, 8 is not a prime number. We take a look at the bottom. It doesn't fit. It's not one of those numbers. So the next thing I do then, I say, if it's not prime, give me any two factors of 8. The first two to pop in my head are 2 and 4. So there's 2 and 4. Notice how I've done it. I've broken it down like branches of a tree if it was upside down, or like roots of a tree if not. I then go to each of my two numbers I've already listed, and I repeat. In other words, I look at my 2 and I say, is 2 prime? The answer to that, of course, is yes. So I put a little circle around it to stop myself from going any further. I go over now to the 4 and I ask myself the same question. Is 4 prime? Look down. Nope, 4 is not prime. 4 is not one of my prime numbers on the bottom. 4 can be subdivided again as 2 and 2. I now repeat again. Is 2 prime? Yes. Is 2 prime? Yes. You will notice now that I have all my branches are finished. They're all complete. They all have circles. I always think of them like oranges at the end of a branch, so you don't go on anymore. Once that's done, now I can just list my factors in order to tell me what the prime factorization of 8 is. So prime factorization of 8 is simply 2 times 2 times 2, or if you'd like to, you may rewrite it as 2 to the power 3. Well, I hope you didn't find that too bad, but let's try another few examples, shall we? Let's try 13. So I start off once again, and I ask myself right away, is 13 prime? Well, in this case, 13 is prime, so I'm done. The prime factorization of 13 is simply 13. Well, that was easy. Let's try another one. Let's try one a little more challenging, shall we? Let's try 48. Now in this case, 48 definitely isn't prime. It's even, for instance, divisible by 3, it's divisible by 4, 6, all kinds of divisibilities. What I'd really like to do with this one now is just come up with the prime factorization. So when I look at 48, I can think of all kinds of things I can divide into it. So I could do, for instance, 4 times 12, I could do 6 times 8, I could do 3 times 16. It doesn't really matter. No matter what you start with, you'll end with the proper prime factorization. So I'll use 4 times 12. And I repeat. To go to 4, 4 is not prime, So I look for prime factorization of 4, which would be 2 and 2. 2 times 2 works. It is 4, and 2 is prime, so it's 2. I go to 12. I say, okay, 12 is 6 times 2. Now 6 is not prime, so I can break that down into 2 times 3, which are both prime. Whereas my 2, the previous 2 from the 12, is prime. All branches are ended, so the prime factorization of 48 is going to be 2 times 2 times 2 times 2 times 3, or 2 to the power 4 times 3. It doesn't matter what factors we got for 48 to begin with, I will always get the same prime factorization. If you don't believe me, why don't you try one? I'll take a few seconds on how we can do prime factorization. I guess the big question is 6 times 8. Why do we 3 times 6 to factorization? That's the point, unless you make a mistake somewhere. Well, there are some really good reasons, above and beyond the fact that next week or the week after you might have a test that has prime factorization in it. The big reason is a lot of our mathematics higher up really involve simplification of large fractions or rational expressions, which are just fractions using algebra. And the easiest way by far to do this is to use prime factorization. Don't believe me? Here, I'll show you an example. So, next test, you look down and you see 48 over 104. And the instructions state express in lowest terms. Now, for many of you, huge panic. 48 over 104, that's a big set of numbers. It's much easier. If it was 2 over 4, most people are okay saying it's 1/2 and that. You know, 48 over 104, that's huge. My God, Jerry's really mean. Why would he give me that on the test? It's not as bad as it looks. Watch. If I express both 48 and 104 as the prime factorizations that we've already done, 48 being 2 times 2 times 2 times 2 times 3, and 104 being 2 times 2 times 2 times 13, I can now take advantage of the fact that if I divide numerator and denominator by the same numbers, or cancel as we're used to calling it, it's completely allowed and legal in mathematics because what you're really doing is multiplying by 1. So for instance, I have a pair of 2's, 2 on top and a 2 on bottom. Really 2 divided by 2 is 1, anything multiplied by 1 is just whatever it is. So really what you're doing is saying, I'm going to cancel this 2 top and bottom, and they go away, they cancel each other out. Keep in mind, I can only do this if it's a product over a product. So I can do the same thing here, and I can do the same thing here. What this will leave me with now, the remainder that I have left, is 2 times 3 over 13, or if we simplify, 6 over 13. 6 over 13 is in lowest terms. It has to be because it has no common factors. Or to use the fancy language for it, 6 and 13 are relatively prime, which means that 6 over 13 will get you top marks on your next test, and better yet, you've simplified a lot because for much of the math you're going to do later on past this point, the more simplification that occurs in the beginning stages, the easier the math is going to be later. Well, folks, that's it for me. I really hope you learned a lot from this. Come back in and cut this out. Well, folks, that's it. Thank you very much for listening. If you have any questions, of course, you can always share them with me, and I'll do everything I can to give you a hand.